Welcome to class number 8 lab. In this lab, we will connect two PCs in different networks using a router. So let's start with PC1 configuration. So currently PC1 does not have any IP configuration. So let's give it IP as per the topology 10.0.0.1/24. And let's give the IP for PC2 as well. So now we have two PCs have configured with the IPs. So as you can see, this PC has 10.0.0.1. So when we try to ping 192.168.0.1, what it is reporting is it is not finding its gateway. So whenever a PC or any device trying to communicate with an IP which is not in the same network, it will try to send the packet to its gateway. In order to send it to gateway, PC does not know automatically the gateway. Administrator has to give the gateway configuration. So in this case, PC1 gateway we haven't not configured it. That's why it has the default value of 0.0.0. So let's configure the gateway. To configure the gateway on the JNS3 VPC instance, the command is same as IP address command. After IP subnet mask, now you can give the gateway value. So in this topology, it will be 10.0.0.254. So now if you do show IP, the gateway value is 10.0.0.254. Let's try to do the ping 92.168.0.1. We are trying to ping PC2. So now what we should see is PC1 is reporting that host is not reachable, but it is not the IP we did the ping for. It is the IP of its own gateway. So whenever PC1 wants to send a packet to an IP in different network, first it needs to able to reach the gateway. Why? Because to forward the packet from PC1 to PC2, first it needs to put the destination MAC address filled with the gateway MAC address. Okay. So as we didn't configure the router part yet, it did not receive any ARP request response for the ARP request for 10.0.0.254. So let's go to the router and configure that part. So when you go to any router or switch, there will be like 2 to 3 modes. First mode is this mode. So in this mode, only few commands will work. Only show commands will work. Okay. So in order to enter into the next privileged show mode, you can type enable, so that now you can see so many options. But in this mode also you cannot assign any IPs. For that you need to enter into configuration mode. So this is only to verify the configurations. So for suppose if I want to see what are all the IPs assigned to this router interfaces, I can use a command show IP interface brief. So currently no interfaces has assigned any IP address, that's why it's showing empty. So let's go ahead, configure terminal. So what this command will do is it will enter into the configuration mode. Now you can apply any configurations that you want. So in this case, PC1 gateway, we want to configure it on Ethernet 1 because this is where the physical cable connected. So let's enter into Ethernet 1 configuration. So if you can see, we have entered into the interface configuration IF, and we are inside the Ethernet 1 interface. So in order to give IP address to the interface, the command is IP address 10.0.0.254/24. Okay, so when you give this command, it is throwing an error, will be ignored while the Ethernet 1 is not a routed port. So in this lab I am using multi-access switch. That means by default it will be a switch, but we can use its interfaces into the as a router as well. Okay, so in order to do that, we need to give a command. We need to tell it's not a switch port, we want to use it as a routed port. So let's give the command IP address again. Okay, and then we can do the same thing for interface Ethernet 2, where we need to configure the PC2 gateway. So no switch port because we want to make it as routed. Then the IP address we want to give is 92.168.0.254/24. Okay. So now we have configured the interfaces. So let's verify it with the show IP interface brief command. So now you can see Ethernet 1 has IP of 10.0.0.254. Ethernet 2 has 192.168.0.254. So you can see additional columns as like status and protocol. So status represents if this interface is enabled or disabled. So if you want to disable this interface, you can disable it as well, but for now we keep it up. Okay, so this is admin status. Okay, and this one is will be up when you have the physical layer connectivity. For suppose if you remove this cable, this will go as down because there is no physical layer connectivity. Okay, so we have the IPs. Let's check if we able to learn these routes. So you can see as we assigned Ethernet 1 10.0.0.254, it learned that particular network, the whole network is directly connected to Ethernet 1. That means whenever a router receives a packet with destination IP falling under this range, it will send it out on this interface. Similarly for 192.168.0.0/24, it will send it out on Ethernet 2. Okay. But you can see some warning here. IP routing is not enabled. As I mentioned earlier, by default it will be a switch, but now in this lab we want to use it as a router. So in order to enable the routing features, we need to run the command IP routing. So what this will do is it will enable the routing services. If you try to enter the same command show IP route again, you won't see this warning. Okay, it has disappeared. So now this router we have configured to forward packets to this network and this network. These two are connected networks. Okay, so now if we go to PC1 and if we try to ping 192.168.0.1, which is PC2 IP in different network, it will work or not. Let's see. It won't work. So what we are reporting is 192.168 timeout. Basically that means PC1 sent the ping request, but it did not receive the reply. So when it did not receive the reply, it will report the timeout because it waited for some time for the ping response. As no one responded, it is timing out. So let's see why it did not work. So when we issue this command, first thing PC will do is, as the destination IP is in different network, it will try to forward the packet to its gateway. So let's verify. Gateway is configured. Yes, 10.0.0.254. Then what it will do, in order to send the packet from here to here, it needs to put the destination MAC address of its gateway. Okay, so how it will learn? Through ARC process. Let's see if it has learned 254 MAC address. Yes, it did learn that. So at this point it should be able to send the packet to the router. So let's see if the gateway is pingable or not. That is also a good troubleshooting step. So there is no issue reaching from PC1 to router Ethernet 1. Okay, so obviously the packet will go from PC1 to router. So once it comes to the router, what router will do? It will check the destination IP of the packet. what will be the destination? Because PC1 is sending the packet to PC2, destination IP is 192.168.0.1. So it will go and check its routing table. So it found matching entry. So to send packet in this network, it can just send it out on Ethernet 2. So based on this information, it will send the packet out on Ethernet 2. Once it goes out, it will reach PC2. Okay. Once it reaches PC2, now PC2 has to respond back. Okay. So to respond back, for the ping reply, the source IP will be 192.168.0.1 and it needs to reply back to 10.0.0.1 because that's where it received the packet from. So in this case, destination IP is 10.0.0.1. So in order to send the packet, first it needs to send it to its gateway because the destination IP is in different network. So let's see if it knows the gateway. See, gateway configuration is missing. That's why the ping did not work. So let's configure the gateway. So once we configure the gateway, sorry, there was a typo. 192.0.1. Okay, so here 0. Okay, yeah. So gateway should be in the same network. If it is not, it won't take the configuration. Okay. So now gateway we have configured. As we configured the gateway on the router as well, so it should be able to ping the gateway. So ping is working to the gateway means this IP is correctly configured on the router side as well. So if you do show up, you see the ARP entry as well. So now PC2 to reply back to PC1, in the destination MAC address field, it will put its gateway MAC address. So the packet will come to the router. So the ping response once coming back to the router, what router will do? Router will check the destination IP. So now the packet is going from PC1 to PC2. So the destination IP is 10.0.0.1. So it will go ahead and check the routing table. So in the routing table, it is stating that any IP 10.0.0/24 falling under this subnet, it can send it through Ethernet 1. So what it will do is it will switch the packet and send it out on Ethernet 1. So when it is sending out, the PC1 is already directly connected, right? So it will change the destination MAC address to PC1. How it will know the PC1 destination MAC address? It will simply send out ARP request from this interface. So if you can verify the ARP table on the router, you can see it knows about 10.0.0.1 MAC address and it knows about 192.168.0.1 MAC address. Okay. So when the packet is going from router to PC1, it will put the destination MAC address of PC1 because these two are in same network. Okay, so basically in this lab, router was able to route the packets from PC1 to PC2 and PC2 to PC1. So in order to establish communication between any two devices in different networks, there should be a device like router able to route the packets from one network to another network. If you have any questions, please refer to the theory of this class, and if you have any questions, please post it in the comments. Thank you.